Hello everyone. In this chapter, we are going to look at linear combinations of random variables. Imagine that you have an attractions park, Park A, and the number of accidents, let them call it XA, number of accidents per year. I know that it's Poisson of 3, let's say, per year. And imagine that in Park B, where XB is a number of accidents per year in Park B, you have is distributed Poisson with, let's say, 2. The owner of Park A buys Park B as well, so now he has 2 parks. Let's call them A plus B. So he asked himself, how is the distribution of A plus B? Is it Poisson? Well, as an average, we can say that there will be about 5 accidents per year in Park A plus B, but it will be good to know the distribution. We know that not all distributions having 5 accidents per year are Poisson. So, with respect to this, we need to put together 2 variables in a linear combination. The learning objectives of this unit are here. X and Y are variables, and A and B are statistical variables or random variables, and A and B are real numbers in the notations to the left hand side. Ax plus B, it's a linear function of a random variable. And expressions of the type Ax plus By are linear combinations of random variables. So linear combination for random variables. For example, expression 2x plus 1, it's a linear function of the random variable x. The expression 4x minus 5y, it's a linear combination of the random variables x and y. In this lesson, we are going to look at linear function of a random variable. And we are going to look at these 2 expressions here. So what happens with the expected value and the variance? Let's look at the expected value, and I start with a particular case to get an idea how this formula works. Let's assume x has 3 values, x1, x2, x3. Then 2x plus 1 will be 2x1 plus 1, 2x2 plus 1, 2x3 plus 1. When calculating the expression value of y, I add these 3 values and I divide by 3. In the next line, I regroup them. I factorize the 2. Then I break into 2 fractions and I get 2 expected value of x plus y. If you want to think more intuitively, imagine that your class sits on a chair. And let's assume x are the heights when the class sits on the chair. Let's assume that the mean height when you all sit on the chair is 1.2 meters. And let's assume the chair is 50 centimeters high. If you all stand now, your expected value when you stand, so you add 50 centimeters to each of you, will be 1.7 meter. So see how this 1 adds here at the end. In the same context, let's look now at the variance. Okay, so let's see what I've done by now. I calculated variance of y using the formula that we know before. The mean of the squares minus the square of the means. I use the 3 values to find the mean of the squares. Then I open the brackets, each bracket, and regroup. So I got 4 times x1 squared plus x2 squared plus x3 squared. The midterm from these expressions after opening the brackets, plus 1 3 times over 3, And I know that the expected value of y is to expected value of x plus 1. Then I start forming here e of x squared. That's 4e of x. I open this bracket here. There are some terms now that cancel. 4e of x minus 4e of x plus 1 minus 1. So see how I get 4 brackets e of x squared, which is this expression here, minus e of x squared. So it's 4 times variance of x. Therefore, if y is 2x plus 1, var of y is 4 var of x. Now see, this 4 comes from this 2 squared. So if I'm going to have another variable t equals 3x, for example, minus 2, var of t will be 9 var of x. Therefore, we have these two formulae that e of ax plus b is a e of x plus b, and var of ax plus b equals a squared var of x. B disappears from the last relation and is normal because think that, let's take some values. What is variance? Variance is the average distance from the mean. Yeah, so it's the average distance from the mean. Well, we take the square and so on, but that's a measure of the distance from the mean. Now, if you add b, everything goes up by b. The values, but the mean itself goes up by b. Therefore, the distance stays the same, so that's why the b disappears in ax plus b. A becomes a squared. As you see here, because I need to square this expression when doing the calculation. So that's how I remember these two expressions. So if x and y, x is a random variable and a be a real number, I can use these expressions to express the expected value of this new random variable in terms of the expected value and variance of the old ones.